Ken, so I'm going to start the recording since nobody will talk to me. All right. So topic 7 is going to be polynomials and factoring. So I think we've talked about polynomials a little bit in the past, so we'll review some of that stuff real quick and kind of move on. This first one, adding and subtracting polynomials, is pretty easy. It might even be a short class today, we'll see. So polynomials, adding and subtracting them, is pretty much just combining like terms. So we add all the x squared together, we add all the x's together, add all the numbers together, that kind of thing. Okay. So first question up. Hi, Chloe. The first question says, find the degree of each polynomial. Okay, now the degree is the highest exponent you can find. And if there isn't an exponent, that means it's to the first power. Okay. You can't see it? Hang on. Try it again here. I couldn't get anybody to answer me, so I didn't know. All right, how about now? Good? All right, cool. Okay, so again, what we're doing today is we're adding and subtracting polynomials. This is topic 7.1, the overall chapter. Again, it's called polynomials and factoring. So again, adding and subtracting polynomials is just combining like terms. And the first thing they asked us about was degree of a polynomial. Okay, so degree, again, is the biggest exponent you can find. And if you don't see an exponent on the variable, that just means that it is 1. So then for 19, we have x over 4. So it's x to the first over 4. So what's our degree on that one? So we're looking for the degree. What's the biggest exponent on that guy? Nope, not the 4. The biggest exponent. So it's x to the first. So what's our biggest exponent then? X to the what? Yep. So the degree on this one is 1. Okay. Now, when you have more than one variable like we do here, so this would be an x to the first and a y to the first. Now, this doesn't come up very often with what we do. This is more of a technicality, if you will. Okay, so if you have x to the first and y to the first, what you do there is you add the two exponents together. So if we add those two exponents together, what's our degree on this guy? Perfect, just add the two together. So this one is a second degree polynomial. All right, so down here, 21 is 21. I don't see a variable, right? So what's our degree on this if there's no variable? There's a guess at that one. So if there's no variable in math, yeah, great. Nice job, Chloe. As I say, in math, how do we represent something not being there? So this is a 0 degree polynomial. So a constant number, or just a regular number, has a degree of 0. Perfect, nice job. Okay, and then the last one here, remember if there's no exponent here, that's technically y to the first. And if you add the exponents together, what's our degree on this guy? All right, so I think Chloe's got it. Beautiful. Okay, so let's move on. Okay, so this says name each polynomial based on its degree and the number of terms. So again, the highest exponent we can find here is our degree, right? So this guy again would be a y to the first, x to the second. This would be x to the first, y to the first. And we know that the number is a 0 power. So what would be the biggest degree on this thing? What's the biggest exponent we can find by adding those guys together? We don't add everybody together, just each term, Chloe. I see what you're doing. So this guy here is going to be 2, right? This guy's going to be 3, and you added 3 and 2 and got 5. Okay. So and that makes sense. But again, you just want the biggest one, not all of them. Okay. So if that's the case, then this would be a third degree polynomial, right? And how many terms do we have? How many separate terms do we have? How many terms do we have here? Only 2? Because the number is actually a term. So how many terms we got? Yep. Beautiful. So that's easy. Just count up the number of terms. All right, so next one. What's the biggest exponent we see on this one? This one's a little less work, actually. And typically, we're not going to have, x to the third, so it's to the third power, right? So it's a third degree polynomial. And typically, this is more of what we'll see. We'll see stuff more like this. You probably won't see stuff like this very often. Okay. All right, so third degree, and how many terms do we have? Just count them up. We have 4 terms? How many we got? We just count these guys up. How many terms we got? I don't know how you keep getting 4. There's 1, there's 2, there's 3. Okay? You understand that? So whatever gets separated by the pluses and the minuses. Okay? So how about the next one? What's the biggest exponent in number 25 here? What's the biggest exponent on this one? Well, that's the biggest exponent. Yeah. So that's going to be a second degree polynomial. How many terms do we have? Just kind of think of it as stuff that's separated by pluses and minuses. Yeah, so there's only 2 terms, right? There's 1, there's 2. Beautiful. All right, how about the last guy? What's our degree on this one? What's the biggest exponent we've got here? Yep. So x to the fourth, that means it's a fourth degree polynomial. And how many terms we've got? Again, terms are separated by pluses and minuses. Perfect. So we got 1, 2, 3, and 4. Excellent. All right, so degree is just the biggest exponent we can find. Like I said, normally you won't have this stuff, but if you have x's and y's, just add the exponents together on the biggest term. Other than that, they're mostly like this stuff right here. Okay, cool. All right, let's move on. So it says simplify each expression, write the answer in standard form. So standard form means biggest exponent first down to a regular number if there is one, which I don't think we have one in this case. All right. So it looks like our biggest exponent is x squared, right? So we're just going to add these guys together. So here is 2x squared plus 3x squared. So 2 and 3 gives me 5x squared. And then we just add these guys together now. We got x's, right? Do the x's next. So we got 3 minus 4. So 3 minus 4 is minus 1. And minus 1 and minus 5 more is minus 6. X. Okay? So again, standard form means x squared is first, x is second. If we had a number, he would be next. We don't have any numbers on this one. So again, you just see what we're doing. We're combining like terms, right? Any questions? You ready? Okay. Let me know when you're ready to roll. All right. Let's go ahead and check out another one here. All right, so this is pretty much second verse, same as the first. So again, let's simplify each expression, write the answer in standard form. So we find our biggest exponents. In this case, looks like it's going to be a y to the second. So I've got 8y squared minus 12y squared. So 8 minus 12, that's going to be a negative 4y squared. The other two guys, there's nothing to add, so we just bring them down in order, right? So this is going to be plus 3y. And then this will be plus 5. Okay, easy peasy. So again, standard form means biggest exponent first, then in this case that was 2, then y to the first, and then the numbers always last. Combined terms, in this case we only need to combine the 8y squared and the minus 12y squared. So that puts our two guys together. And then the other guys, we just had to bring them down in order. That's it. All right. Questions on that one? You good, Chloe? You don't need a minute? Okay. Just making sure. All right, so this was a little fancier, but not much. So it says again, simplify each expression. So it looks like x squared is our biggest guy again. So I've got a minus 7, actually it's z squared, So minus 7 plus 5, that's going to be minus 2. Minus 2 plus 2, these guys all canceled out. So they're all gone. So it turns out in this one, all we've got is 3z minus 5z, so that's negative 2z. And that's our answer. Oh, it wasn't so bad, was it? All right, let's go ahead and check out another one. All right, so this guy looks like our biggest one is a 4x squared. We just bring him down. We don't have anybody to add him to. And we say we do x's, so I've got minus 2x plus 5x, so 5 minus 2, that's going to be 3x. And then all we've got left is the number, so we've got 7 plus 3 plus 10. That's our guy. So hopefully we've got the hang of this. Sure. Looks like Chloe left us for a second, but she's back. It's a good thing since she's the only one that talks. All right, Chloe, we good? Okay. All right, so now this isn't really any different than what we were doing. So it says add or subtract. So we're still just combining the terms together. So in the last one, we just written them all together. This is really the same thing, except they got this parenthesis going on. That's about the only difference. But again, we're doing the same thing in this case. We're saying, okay, we'll take our b values here. So I got 3b, 7b. So that's 10b. Then I've got minus 8 plus 4. So we have 4 minus 8, that's going to be negative 4. So that's our guy. Okay. Then we do the same thing here. Again, look for your biggest exponents. Looks like on this one, it's going to be an x to the third. So let's start with those. So I've got minus 7x to the third. And then I've got minus 8 x to the third. So minus 7, minus 8 more. That's going to be minus 15 x to the third. All right. Then let's move on. Do our x squareds here. So we got a 2x squared and a minus 3x squared. So 2 minus 3, that's minus 1x squared. They probably just write minus x squared, right? Then the rest of it is just terms we can just bring down, right? Because we've only got an 8x, so we'll bring him down. And we've only got a 4, so we'll bring him down. And that's it. Questions on this one? I guess these two. All right, let's keep it going. All right, so this one says add or subtract. In this case, we're subtracting. So there's different ways to go about this. For me, I find the way that I make the least number of mistakes is to switch all the signs. I'm going to make him positive. He's going to be a minus y squared. He's going to be a minus y, and he's going to be a minus 3. Then we start putting terms together. So I have 5y squared minus 1y squared. So 5 minus 1, that's going to be 4y squared. Okay. Then I've got minus 2y and minus 1 more y. So minus 2 minus 1, that's minus 3y. And then last we've got the numbers here. So I've got a plus 1 and a minus 3. So 1 minus 3, that's minus 2. And there's our guy. So with the subtraction, obviously, you got to watch your signs a little closer. Questions on that one? Like I said, hopefully this is pretty easy. Okay, let's try another. All right, so again, if you can keep the negative sign straight, that's great. I personally would prefer to change them. So he's going to go plus, he'll become plus. This one will become minus, and this one will become plus. Okay, then we start combining terms again. So in this one, looks like our biggest term is a to the 4th. So I got a minus 7. Why? Because think of it this way. If you have, let me erase this here real quick, hang on. This is really the same as when you have a minus sign out in front of a parenthesis. This is the same as multiplying the whole thing by negative 1. But the lazy math guys don't write the negative 1. Okay? So then you can think of it as like a distribution thing. So if I do minus 1, okay. So if I do minus 1 times minus 8, that's going to be plus 8a squared, right? Now if I do minus 1 times a, that's minus a. And if I do minus 1 times minus 7a to the 4th, I get plus 7a to the 4th. So you can totally do it that way. That's fine. Okay. But what I noticed was basically if I switch this to a plus, then I have to switch everybody else. So he becomes plus, he becomes minus, and he becomes plus. He becomes plus, he becomes minus, and he becomes plus. Okay? Whatever works for you. There's different ways to think about it. Okay? All right. So pick our regular scheduled program. So we have a minus 7a to the 4th, and we have a plus 7a to the 4th. So these guys canceled out, right? So we move on to the a's. Here I've got minus 1a, and I got minus 1a again. So minus 1 and minus 1, let's go minus 2a. All right, let's go on to the last guy here. Oh, I missed one, didn't I? But that's okay. We can just put him up front here. I have minus 4a squared plus 8a squared. So I have 8 minus 4, that's going to be 4. And remember, the a squared goes first. Like that. So I skipped the a squareds. and I did the a's first, but it was no harm, no foul, because I could go back and put the a squareds together and then just put that guy as the first term. So again, standard form means biggest exponent first. So the a to the second is going to go before the a to the first. All right. Questions here? Okay, Representative Chloe. Talking for the mute group here. All right, so this one's a plus, so we don't have to mess around with that sign changing thing. All right, so again, same thing we're going to say. We've got 4m squared and 2m squared, so it's going to be 6m squared. And we move on to the m's. We've got a minus 2 and a plus 2. They just cancel. All right, and then we move on to the numbers. We've got 4 minus 5. That's going to be minus 1. So that's our answer. Okay. So it's usually easier to do adding than subtracting. The subtracting, you have to mess around with the signs, and sometimes that messes us up. But that guy there was pretty easy. All right, we'll check out a few more and we'll call it a day. So this one says, write an expression to write each situation. It says, find the perimeter of the rectangle. Perimeter is the distance around this thing. So from here to here is x plus 1. Since this is a rectangle, that means this side is the same. So he's also going to be x plus 1. Okay? And then when we look at the other one here, from here to here is going to be 3x minus 1. So that means from here to here will also be 3x minus 1. So the perimeter just means add everybody up. Okay? So again, start with the x's. So I have x, 3x, so 1 and 3 is 4, plus another x is 5, plus another 3x is 8. So that means that part's going to be 8x. Okay, and then we do these guys. So I have a plus 1, minus 1, that's 0. Plus 1 and minus 1, that's 0. So it turns out this is our answer here, is 8x. Okay, so we did there when they ask you for perimeter, you just add up everything all the way around. And it turns out in this case that the numbers canceled out. Now you can always line these up and do it too. So I've got 3x minus 1, I've got x plus 1, I've got 3x minus 1, I've got x plus 1. And you can add them up like that by columns. Minus 1 plus 1 minus 1 plus 1, that's 0. And I've got 3, remember these are 1s. So 3, 4, 7, 8. 8x plus 0 or just 8x. Okay? That makes more sense to you, go with that. Okay? Check out a couple more. All right, so this one says, a cube has square sides with area x squared plus 24x plus 144. It says, what expression represents the surface area of the cube? Okay, so this is kind of a visualization thing. So we got a cube. Get ready for some bad drawing. All right. A cube is basically a box, right? So the question is, if the area of a side is all this stuff, how many sides do we have? How many sides are there to a box? many sides are on a box? 6. So there's 6 sides, and each side is that. So the surface area of the entire box, or cube, is going to be 6 times x squared plus 24x plus 144. Okay? Now, we could distribute and multiply this thing out. Nah. That's a good answer right there. There's nothing wrong with multiplying it out. If you multiplied it out, you'd get bigger numbers, and it would still be correct. But they didn't ask us to do anything else to it. So we can just multiply it by 6 out front, and we're good to go. Okay? And again, if this was a multiple choice test, if you saw it like this, then we're good to go. But then if you saw something with bigger numbers, that's like, they probably multiplied these guys out. But chances are pretty good that they would not. Because as I mentioned probably 1,000 times or so this year so far, well, actually last year, math guys are lazy. So they're probably not going to write all that out. They're probably not going to multiply all that. All right. Couple 3 more and we're out of here. All right, so this says a rectangle has a length of 5x plus 2 and a width of 4x plus 6. What is the perimeter? Okay, so this is the same thing as last time, right? So we're going to have 2 sides that equal 5x plus 2. And we're going to have 2 sides that are 4x plus 6. They're running out of space. Yikes. Here we go. I guess I have to put the answer over here. So if we add these guys up, we got 2 plus 2, that's 4. 4 plus 6 is 10. 10 plus 6 is 16. So 16 is going to be that guy. And then we go ahead and do 5x and 5x, that's 10x. 10 plus 4 is 14. And 14 plus 4 is 18. So 18x plus 16. That's our guy. Okay? So just remember when perimeter, when they give you 2 of them, you got to have 2 more. Okay? All right. It says, which expression is equivalent to this? Okay. So all they're asking us to do is put these guys together, right? So with these kind of problems, when you're doing multiple choice, do part of the problem and then look at your answers, right? So the first part here, I've got x squared minus 4x squared. So that's going to be a minus 3x squared. We look at our answers. 5x squared. No. Minus 3x to the 4th. I'm sorry. No. Okay. So now I'm down to these 2 guys right away, and I've only done 1 step. All right, so next up, we've got 3x minus 3x. That means 3x minus 3x, these guys cancel. So I'm only going to have 2 terms, not 3. Okay, there only has 2 terms. That's my boy. I didn't have to mess with the rest of it, did I? Pretty cool, huh? So keep that in mind when you're doing like a multiple choice test like that, or you're doing ACT or something, SAT, that work out the problem step by step. And every time you do a step, look at your answers, because a lot of times you can eliminate things that are wrong. Okay? So even if we ran out of steam at this point, if we didn't know what to do after we added the first ones together, we still would have a 1 out of 2 shot at getting it right, as opposed to a 1 out of 4. All right, last one. So it says, what is the sum of these 2 guys? So same kind of deal, right? So I've got minus 2x squared and plus 3x squared. So that's just going to be an x squared, right? Wrong, 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 wrong. Ha! How about that? All we had to do was add the first term together, and the answers were so different that we could figure it out just like that. Fabulous. Questions, comments, complaints? All right, Chloe, well, I want to thank you for showing up today. For all I know, everybody else just logs on and walks away, so I have no clue. All right, I'm going to shut down the recording. Let me get attendance real quick before you guys go. A moment, please. Thanks for listening to me, but that's all she has to do today, okay? So don't worry about getting in the class. All right, we are good to go. And tomorrow's already Thursday, so only 2 classes this week. Not bad. All right, we'll see you then. Secondary government.